Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this video, we're going to be creating here an AI e-commerce chatbot using Python and LangChain. So without extended time, let us start our tutorial right now. Let's have a look about the data flow summary. So we're taking here one CSV file which is containing here all of the informations about the product. And this product is actually basically coming from the Amazons. So you can also see these data sets. So this is the data set that you can see. This is called the product data.csv. So here you have the product ID, the marketplace, and you can see Amazons, the country, the main image ID, the domain name that you can see. It have domain as well as the subdomain. Then the bullet point, the you can see item underscore keyword, as well as it have the material, and then it also have the model number, the product type that you can see cellular phones or the homes or the shows like that. So this is a whole data set that you can use it here to building here this AI e-commerce chatbot, and you can using here the Amazon product data sets. And after that, what I can do is simply going to truncate this data set and as well as filter it so that the if it have any noisy kind of things, it will automatically remove them. And then after that, you convert it into the data frame. I'm talking about the Pandas data frame. So it's called the Pandas data frame. And after that, into creating here an embedding, and you're going to creating here the embedding using this item underscore keyword, this column using this one. We're creating here and vector embedding. So you can also see it on here. You can see here that it having a column which is called the item underscore keyword. Okay, and you're creating here and vector embedding for that. And after that, we are going to store it inside and vector store database, which is called the Redis. It's a cloud style database. You can easily use it and access it, and you may getting here 30 MB of free memory. Okay, you can also do the subscriptions. You can get it from here, and you're going to using here this Redis FLAT index setup. To set up this one in the cloud. I'll show you that. And after that, you're going to combining here our product data, and then the vector that you created using here this items keyword, we push back into pushed into the Redis, not push back, push into the Redis, our vector database. And after that, user can give one input. It's nothing but in the form of natural language processing. You can also tell as a prompt. And then our large language model, and you're going to using here the free and open source model from Groq, so that you can see Groq. And this Groq model, it also has the comma separated keyword. Why comma separated keyword? Because if I see my data set, you can see this is an item keyword. You can see mobile, mobile covers, the back covers, the mobile, the case, the phone case. You can see it's nothing but some kind of keyword. Some kind of keyword that you can see. So what you can do basically is simply going to stack it and try to using the large language model with the comma separated keywords. And after the same thing, after that, you're going to creating here an embedding that you can see vector embeddings using here this the embedding vector that you can see on here, the same thing. And after that, you're going to using here the Redis KNN search. Okay, is same as like our machine learning algorithm. Okay, KNN. So you do here one KNN search and try to search in the product. Let's say I'm going to searching here the latest 3 product. So it will automatically search in it from this Redis vector database. And after that, you show here our product result summary. Let's say our large language model recommend us, let's say 3 products. Let's say one is nothing but let's say iPhone, and let's say another one, let's say the Google Pixel. Let's say third one, let's say Samsung. Okay, it will recommend me based on that. Okay, using this KNN search. See, KNN search. Machine learning is also used in GNI. And then after that, we simply going to using here our large language model, our Groq model, to generating here a human-friendly response and try to show it in our applications. And optionally, you can continue the conversation with the follow-up Q&A. So you can using here Python while loop to do the conversations. But you're going to using here and library called the Gradu. So using this Gradu library, we basically creating here the interface. Okay. So you can also implement it in your local machine as well. But in my case, I don't know why it's taking time because I'm using CPU. So that's why I am not able to actually process it earlier. So it's better you can using here the Google Colab. So in Google Colab, we are just going to create in the interface using here this Gradio library. If you do it in the local host, you can easily using the Flux or Streamlit as well. Okay. Now let's see what are the module and the purpose of that. So the first module that you're going to use it, that's called the google.colab.drive. So it's basically for accessing the files in Google Drive that you can see that's our CSV file. And I'm simply going to upload it in my Google Colab. I mean, not Google Colab, Google Drive. And simply I'm going to access it in from our Google Colab code. So we're going to using here this Google Colab.drive. And after that, you're going to using here a library called Pandas. And this library is helpful to loading here any kind of data sets. So load and manipulate the CSV product data. Then the NumPy, you can see the most important one, it's basically used for vector formatting and the numerical operations. You can do the matrix multiplication on that. And then the SentenceTransformer, the most important one, because you're going to using here the free and open source model. Everything is free. You're not going to using here any closed source, I mean paid models. So SentenceTransformer is also needed for generating here the embedding from the text. But if you're using here the paid version, I mean, I'm talking about the OpenAI. So you can also using here the by default or built-in OpenAI embeddings. And the Redis, you can see Redis is nothing but our vectorized database that you can see. It's nothing but for a store and search the vectorized data with the metadata. Then you're going to using here the LangChain.prompt, so which one help us to formatting the prompts for our large language model inputs. And then you're going to using here this LangChain chains. So it's basically creating here a chains together the prompts and the large language model. It's also important. The prompt and the large language model, you're just creating here a chain like that. And after that, we are going to using here LangChain.memory so that it can remember, it can also remember the previous the conversations. Okay. So maintaining a chat history across in the turns. If you type anything in the chat GPT, so it will also store your data in their memories. Okay. So you can maintain the chat history as well that you see in the messengers or the Instagrams. And the LangChain.Groq, so it's basically for connecting the Groq hosted LLM for the inference, because you're going to using the free and open source model from Groq. As well as you can also using here the Llama, and you can installing here the DeepSeek R1 or any kind of model you can also install. Then the time module, it's built-in module in Python. So it's basically for the pause the execution for better UX while we do it for raw inputs. I mean, I'm talking about the while loop. Then you can using here this module time models. So those are the module and those are the purpose of that, why you should actually use that. And now first we see how can we basically creating here an database in our Redis. And after you also see that, how can you also accessing here the API key from the Groq as well as see the models. So just go on the Google and search for the Redis, and you can getting here an interface. Just click on here and log in with your Gmail account. Then you can get in here and Redis console like that. You can see Redis console. So cloud.redis.io, this is nothing but my database that you can see. So what you can do, I am simply going to creating here a new database. Let's click here to new database. So it will creating here a new database. So you can see select plan, you can see 30 MB just for a single DB. You can also using the pro versions or the essential version. I don't think that it's not so costly. Okay. So you can select in the plan because you are using the free and open source one. So one database, and now you can click on create. So to creating the data set, I mean database. Okay, so you can see you can import the data on here, and then you can also connect with the Redis CLI. And then you can see the data persistence. So now connect using Redis CLI. You can see your database will be ready in a few seconds. So after that, you can also connect this Redis using your CLI, or you can also use it using here Redis modules. So you can installing here this Redis CLI that you can see. You can copy here your CLI and you can run it. Otherwise, you can also using here this Redis client. So you're not going to using here this .NET. You can selecting here your programming language. So let's select here the Pythons. And then I can basically using here these ones. Okay. So I'm not going to show you the passwords that you can see. So we can simply going to copy this out. Okay. We can copy here this code. So you can click here and copy. So the password is also be copied. So I'm just going to pause the video. And after that, I'm going to show it you later on. Okay. Okay. So I copied this with the passwords. And then now let's go on the Groq. So you can see this is the Groq cloud. Just go on the Google and search for that, and already creating so more amount of videos using here this Groq. So you can see how what are the model are actually available. You can see Kimi Cat in start. It's also available. Maybe it's nothing but a Chinese AI model. Okay, and you can see Llama 3.3 70 millimeter that you're going to be using it. So you can use any of the model. I don't know it's able to generate or not. I'm super excited about the Kimi Cat too. Okay, cool. So we can you see what are the feature it have. You can just go on the API key section and you can access the API key from here. Okay. So now I am simply going to go on the code and try to explaining all the code line by lines. So those are the modules needed in order to do this code AI e-commerce chatbot. So I'm simply going to first go on the runtime. Let's go on the runtime and check in the runtime type. So it's nothing but T4 GPU. So I can simply going to close it and I'm simply going to the shift enter. You can also clicking here this run button as well. Then after that, let's opening this out as well. And then it also mounting our Google Drive. So I am simply going to also shift enter to mounting here our Google Drive. And because you need to also accessing here our data sets and I upload it in my Google Drive in a folders and you can easily access it. You can also upload it on here. You can also upload it on here and you can easily access it. But I just uploaded the Google Drive so that I can also share with you the data set. You can also get this data set from the Google, no, not Google actually, from the Kaggle as well. But in the Kaggle, the data set is quite big. So for the testing purposes, I'm just going to using here a simple data set, which is nothing but 1 4 MB like that. So it's not so big data sets. Okay, and you also using here and the minimum version of the data in here just for the processing purposes. But if you do it for your commercial purpose, you need to using here this the full data set as well. Okay, now let's wait for a few minutes, and after the after installation is done, then I will back again. Okay, so now you have to give the permissions to permit this notebook to access the Google Drive. So let's select the Google Drive and selecting here my Gmail account. Click on continue and click on continue. And then you can easily accessing here our Google Drive. Now you can, it's not needed at all. You can also give it here an exclamatory sign before that. If you give it, it don't give you any kind of errors. You can see error is gone. Okay, it's does give it some warning. So I can now clear the output. It's not needed at all. Now after that, what I can do, you can see mounted at content drive. So in our drive, you can see we have my drive, and then you can see that e-commerce. Okay, you can see e-commerce. That's our data sets. Okay. Now, let's try to see this code right now. So first we import here the NumPy as NP, then Pandas as PD and time module. We already told you that why we basically using here the NumPy and the Pandas library as well as the time library. Then you can see from redis.command.search.field, we import here the vector file as well as the text field, sorry, vector field, text field, tag field, and the query. So it's nothing but for creating here and searchable vector interface. And this query is nothing but for querying the Redis with the vector fields and the metadata. So this is nothing but the basics of the Redis operation that you can see vector field, the text field, the tag field, and the query fields. Okay. Now you also import here the Redis and also the time. Okay. It's double time ho gaya. So you can remove one of them. And then after that, you can see we're creating here a connections. So Redis connections equal to Redis, and then you give it here the host as well as we give it the port and decode response equal to true and username is default and this is our passwords. So I'm not going to showing you. I'm just going to add it in the later on. Okay, you will get it in from your Redis cloud. And then after that, you can see we initialize here the two variable. One is for the max text length. Another one is called the number of products. So max text length is basically the truncate the long text to the 512 characters. Okay, 512 characters, because in our data set we are using here the items underscore keywords. So it has so many keywords. So just truncate the long text into 512 characters and loading here the 100 products. Sorry, not 100, not 1000 products. Okay, so this is nothing but you said that this is nothing but the Redis connection. Okay, And after that, from this bell, we basically taking here this max test length, which is 512. And after that, we are going to loading here our datasets using pd.read underscore csv. And you give it to the path that you can see content drive, my drive, e-commerce, and the product data.csv. And then we give it here the converters. You can see converters is equal to bullet point and auto truncate and item keyword auto truncate and item keyword also the auto truncate. We just initialize it like that. And after that, what we can do, we can simply go into creating here a unique primary key. We're creating here a unique primary key by combining here the item ID and the domain names. So domain name is nothing but our Amazons. You can see that it's nothing but the Amazons. You can see domain name amazon.in. Okay, we need to close it. Okay, amazon.in and amazon.com amax. You can see so many domain name it have. It also have the subdomain as well. Okay, so you can see we just simply going to add all of them. And after that, what I can do from this item keyword, we replacing or we just removing here the nan below. You can see np.nan and we place it as a true. And as well as you can see, we simply going to removing here the nan value and subset we're taking here the item keyword because we're just working on the item keywords. And in place is equal to true and we're just resetting the index. That you can see resetting here the index. And now after that, what you can do, we basically getting the first thousands product with a non-empty item keyword. Okay, non-empty item keyword, as you can see. So product metadata is equal to all products dot underscore df dot head and number of products. So it's nothing but the thousands and to dictionary. We're simply going to convert them into a Python dictionary indexes by the row numbers. Indexes by the row number. You can see in orientation is nothing but the index. It's in the case of the row numbers. And you can see all products df.head. Now you can simply run this out and you can see the outputs. Okay. So PD is not defined because we are not running it yet. So what you can do, I'm just going to replace it and I'm going to pause the video right now. Okay, so I give the passwords of my Redis. Now it will automatically load it. Actually, so that it's not needed at all. So you can see it will load in this data set that you can see. It has the item ID, the marketplace, the country, the main image ID, the domain name, the bullet point. You can see item keyword, which is important. Okay. So what you can do, you can also do the data processing. You can do the data visualizations on the data set as well. But I'm not going to do that on here. And after that, you can see we just imported here the sentence transformer from the sentence transformer. So from sentence transformer, you're going to importing here the sentence transformer and you're going to creating here a model of that. So sentence transformer and sentence transformer all DistilRoBERTa B1s. So it's not needed at all right now. So you can, here you go, mouse coming. So item keywords, and we're taking here all of the item keywords, which one is coming from this product underscore metadata dot keys. So store it inside and product metadata because this is nothing but an Python dictionary itself. So you can generally access it using this Python product metadata dot keys. And you're creating here and list comprehension and we're getting here all of the item keywords. And after that, we're simply going to parsing here all of the item keyword in our sentence transformer that you can see in the sentence transformer. So item keywords for sentence in item keywords and passing here the sentence in our model.encode. And it will encoding it for the all of the item keywords. Now you can basically see the length of the item keyword vectors and the product metadata that you can see. Now the final part is here. Final 2-3 part is here. So now we need to creating here a functions that's called the load vectors. It's basically for the extracting here the 768 dimensions vector for each of the things in here that you can see. So you simply going to using here this load vector to creating here and vector register for the Redis. So you can see taking here a client and it will taking here a product metadata. So product metadata is nothing but is coming from here that you can see, and one vector dictionary and as well as one vector field name. So you can see one metadata is coming on here, item ID in the form of dictionary, or you can say JSONs. So marketplace, Amazon's country, India, main page ID, domain name, the bullet point, and item keyword, the material, the brand, the color, the item name, the model number, and the primary key. You can see also have one primary key. Okay, it added here. You can see it added here. We see if I see the code, it will just add it here, the item ID and the domain name. That you can see item ID and the domain name. Same thing on here, item ID and the domain name. Okay. Now what you can do is simply going to see this load vectors. So we're going to using this client because this is nothing but a client of the Redis. So client.pipeline, and we give it transaction as a false, and then we taking here all the product metadata dot keys. I mean, this is the keys and this is the values that you can see values. And then we're simply going to creating here a hash key. So product, the index number, product metadata, index number, and the primary key. You can see primary key is nothing but a unique key which having the items ID as well as my domain names. And then we're creating here a product metadata dot index, and as well as creating here and vector dictionary that we're passing on here. And we're passing here index number and convert this as type into float 32 and also convert it to the bytes. And then we add it in our item metadata that we have, and we pass it to the p.aset. It's nothing but pushing the data in the Redis. So p.aset, and we passing here the key, and mapping is nothing but my item data. So to pass in the data in the form of the dictionary, Python dictionary, you simply going to execute it. And then after that, into creating here and flat index. That's called a Redis flat index. So you can also see it. You can see Redis into creating here and Redis flat index. So we can say that this one. Now we passing here our Redis connections, the vector field name, the number of vectors, the dimension. You can see dimension is 512 and distance matrix is let's say at 2. So creating here Redis connections.ft.create index, and creating here using here this vector field, and passing here our vector field name, the flat, the type is float 32, dimension is vector dimensions, distance matrix is distance matrix, the initial cap is number of vectors, the block size is number of vector as well. And after that, we passing here product tag title is product type, and text field we give it here the item name, which item name is coming up, and text field is also taking the item keyword, and tag field is also taking the country. So based on this country, to just go, try to recommend it. Let's say I'm Bengali, so I love the mutton kasha, biryani, or rasgulla. But the people who are from Mumbai or Pune, they maybe like the chole bhature like that. So because I am Bengali, and I am from Kolkata, so that's why the rasgulla is my favorite. So same thing, you need to also give it here the country tag as well, that you can see. So creating here a flat index for that, and the country is also important, and based on this country, they can also recommend the product. Okay, now let's say we initialize here the item keyword. Okay, it's called Redis connections. So I have to make it R, or I have to change the variable name because I copied the code from this the Redis cloud. So let's try to changing here this one, and after that I will come again. Okay, I'm just talking about here this variable name that's called Redis connections, because by default I'm copy the code, then it's just nothing but R. Okay, now let's go in the code. Okay, so now you can see we're just getting here an item keyword embedding field, and which one is nothing but an item keyword vectors. Then you have the text embedding dimension, which is nothing but 768. It's nothing for extracting the item keyword and compute here the 768 dimension vector that you can see for embedding for each. Then number of product, how many product it have? It nothing but have the 1,000 products. And to printing here, you can simply go to printing this out. So indexing. So you can see string is equal to number of product, how many product it have products, and we simply can do flush all the data. So Redis connection and flush all. We're just flushing all the data on the back to the database. And then we're calling here this create flat index, where we're passing here our Redis connections, the item keyword embedding field, the number of products, the text embedding dimension, and the cosines. This is the cosine similarity, right? And we also load here our vectors. Okay, now you can simply go into shift enter. Now, okay, create flat index is not defined because we are not running it yet. That's why. Now you can see loading and indexing plus 100 plus product. You can see it's executed correctly. Cool. Now, okay, it's not needed. You install it before. Now we need to do the main things. We need to connecting with our large language models. So we first going to import here langchain.prompt and import here the prompt tablet so that you can creating here and prompt and you can just combining here with some of the variables. And then LangChain Groq, we import here the chat Groq that you can see. And then we give it here model Llama 3.3, 70 versatile, as well as I need to give it to here my API keys. So I'm going to give it to the API keys right now. Okay, so I just give the API key. So I'm not going to use it again because I'm going to revoke this one so that you cannot use it. Okay, because it is free. Why you need to store it? And after that, we simply going to prompt, we creating here a prompt templates. And here we have our product descriptions. So create a comma separated product keyword to perform a query on an Amazon dataset for the user input. You can see product descriptions. And then after that, we're creating here a chain. So let's say from langchain.chain, we're creating here a chains, and we're creating the chains using here our large language model and the prompt. And then you can see an user inputs. Let's say, hey, I am e-commerce chatbot. How may I help you? Just show here an user input, and it show the user is telling like that. Then after that, we running here the chains that you can change. Now we need to using here our vector resource. So which one is Redis itself? So top k is equal to 3. Just starting here the top 3 product, and query vector is equal to model dot encode. Model is nothing but our embedding model, which is SentenceTransformers, and keyword and as type is equal to float 32 and 2 bytes. And then we need to prepare here the query. So because a query f string, and we are going to using here this KNN algorithm, and starting here the top k item keyword embedding field, and the vector parameter as a vector short by the vector store is just going to short it, and here you give it here pagging as a 0 and to top k, and return field as a vector restores the item name, the item id, the item keyword, and we simply dialect it with the 2. Okay, don't worry about this code. I know it's quite tough, but you can exercise this code, and you got this code in the description in the GitHub links. Then we have the param dictionary, which is vector param and the query vector itself. Now we can execute the query. So redis connections.ft, and search we passing here our queue, which is query itself, and query param we passing here our param dictionary, which is nothing but our vector params. And we're creating here a variable called full result string. So we're simply going to join our product.item name, product.keyword, and product.item. I mean, just we're simply going to um, beautify it. Okay. And now we need to also add here the conversation buffer memory, because we also see it in our explanations. You can see that we are using here an conversational flow maybe here. You can see LangChain memory. So we're also using here and conversational buffer memory. Okay, here you go. Now you can say template, you are a chatbot, be kind, details and nice, present the given query, search the result in a nice way and answer to the user input, and don't ask question back, just keep the context. Okay, because ChatGPT asks the question back. Okay, so don't do that in our applications. The chat history and is the human and is the user message and chatbot. And creating here a prompt template. So input variable is the chat history and the user message that you can see, pass it in here in our prompt templates. And templates is template itself, and conversation buffer memory, we give it to here our chat history. And then anything wrong here? And then we creating here and large language model chain. So you can say that, okay, this is a chain itself. Okay, and here we have our okay, you need to give it here a comma. So you need to give it here our LLM chains, so which is LLM chain itself in the conversation. After the conversation buffer memory to creating here a chains. So give it here chat Groq and our model, and it also give it to here our API key. So let's copy this API key as well, and I am going to paste it here. And after that, you give it your prompt, and verbose equal to false, and memory is equal to memory. We just show that you can storing here our chat history. And the answer is equal to LLM chains, the predict and user message and full result string that you have in here. We created that and we beautify it. And then you can simply going to say the user input as well, and you can say time.slip so that it look the codes. And you're creating here and while loop, we let's say okay, we don't need to using here the while loop on here. We don't need to follow up the questions. So you can just taking here one single input. and you can printing this out. Okay, so now let's try to running this out, and after that I'm going to asking here equations. Okay, so let's say I am just going to pasting here equations. So let's enter. Let's say I'm looking for some earring for my girlfriends actually, but not like that actually. So uh, that you can see it also asking for that. Anything else you want to ask about this topic, you can create a follow up. So you can see that we actually got in here our answers. Let's say it's just TUD earrings, the drop earring, the hoop earring, the dangle earrings, and you can see the Amazon Essentials, the Kate Spade New York, the Babluber. You can see, and you can see it's cool. It's also give the response. Okay, now let's say what is the product ID? That's the product ID. So yep, the product ID is provided. You can see the Amazon Essential is Ballot Paper. This is the product ID. It's coming from the CZ file. Cool. The Amazon brand, Solimo, design and multiplier, back platen, alphabet C, printed, soft back case, mobile cover, the Technosperk, and this one as well. Cool, not so bad. So now it's time to creating here our Grady applications. So sorry for some interruptions. Once call is coming, even though the electricity is also gone. So then that's why I need to restart it again from the sections. Okay. So what you're going to do basically, we're simply going to using here a library called Gradio. So you already installed it before. You can see Gradio, and you can see I already imported here all of the module, but it not necessary at all. But if you are going to creating here in a one at a time, I mean in one shell, you can just import here all of the important library. Then you can also add them all of the code that we do before. Okay, so it's not needed at all. We can basically removing all of them. It's not needed. And now after that, what I can do, we creating here a functions called chat with bot, and which is taking here a history, which is nothing but my memory itself, and also taking here one user input. And then the bot response is nothing but my LLM chain that we created before, that you can see this LLM chain that we created, and LLM chain dot predict, and we passing here user message as a user input, and we using here time dot sleep so that it locals, and then we add it to our history.append. I mean, you're simply going to store it inside a list so that you can show it later on. So history.append and user input and the bot response. And then you're simply going to returning the history and this null string. And then we're creating here a gr.block as a demo. And we give it here a markdown. Let's say AI e-commerce chatbot. You can say that e-commerce chatbot like that. E-commerce chatbot. Okay. I just make this UI super simple, not so fancy. Then you can see chatbot equal to gr.chatbot, and we have an text box for taking the message and another text box for sending the request. And send the click, and when the user send the click button, and it will calling here the chat with bot methods, and inside its input it will taking here chatbot and the message itself, and output it will show the chatbots and the messages. Same thing in the case of message submit as well. Now we can simply go to launching this out. It's not so fancy, it's just simple applications. Okay, you can also make it cool. You can add some types of interfaces, some kind of themes. You can simply add it on here. So I'm going to click on here to see the application in live. So it will opening in here. So you can also do it in your local host as well. So now you can see it's a AI e-commerce chatbot, super simple UI that you can see. Now I'm going to asking here a question. So uh, let's say I am, so I can say that I am looking for a smartphone for my sister. Okay, now click on send and wait for the output, and you can see it processing that. Okay, cool. So you can see that it also gave me some response. I'm looking for a smartphone for my sisters. So I'm happy to help you find a good smartphone for your sisters. So you can see budget friendly. So the Redmi Note series that I am also using, and Samsung Galaxy S series my mom is using, and mid range Google Pixel it's also I am also using like that. OnePlus that's my वो मेरा पुराना फोन था, एंड फ्लशिंग एप्पल आईफोन वो था 11 सीरीज का, वो पापा के पास है अभी. Then some popular phone accessories that you can brought it from here. You can see phone cases such as Amazon brand. You can printing this out, as well as you can see the product ID and the screen protector. And also operating system, you can choose Android or iOS, display size, resolutions, the camera quality and features, and let's say better battery life and charging speed. You can see everything on here. Okay, when you're choosing a smartphone, considering factor like that. Okay, yes, it's important. Okay, so let's say I want to buy a laptop. Okay, and click on send. Okay, not one or two, it should be one, one two. Okay, because one is nothing but short from one two. Okay, that's my bad actually. See, I just give it here a wrong prompt. So I happy to have your gear laptop to meet needs. Budget friendly, you can see Lenovo Dell Inspiron I am using, and Razer MSI, my previous one I also use this one, and Apple MacBook Air, that's my M1 chip I am using before. Okay, cool, not so bad. You can see price is money under the $500 to $2,000. So you can see if you're looking for phone, you can with your new laptop, you can see it also storing here our history that you can see. Okay, cool, cool. So that is our AI e-commerce chatbot. So that's it for today. Now I hope you enjoyed this full tutorial, and make sure to subscribe to the channel and share it with your friends. So thank you and bye bye and namaste.